Hey everyone, and welcome to the Rectov, your one-stop community for all things Rust and Web3 security. Today we have three co-hosts here, me and Igor, our co-founders of Rectov. We're developing a new generation of security reviews and introducing a modern approach to research in Web3. Also, we have a Blokarl here. He's an awesome Solidity security researcher. Recently started to learn Rust and follow his YouTube channel for more Rust educational videos. And finally, we have Timur here. He's an OG security researcher, a mentor in Rectov community. He's a CTO of TrustBlock and also an ex-Halborn Rust tech lead and just an awesome person. Welcome, Timur, and thank you for your time today. How are you doing?
Awesome. Thank you for having me today. Looking forward to a great call.
Awesome. So I'll start with the first question. So can you tell us more about yourself, your background, and about your Rust and security experience?
Yeah, sure thing. Actually, before moving to Web3, I was mainly in Web2 cybersecurity field. I was working at Web3 Security, NetSparker, Acunetics. I mean, those guys created like a big, let's say, OG web security scanner that's used in like many Fortune 500 companies. But then eventually I shifted towards Web3 because I saw that there are many opportunities when it comes to security, which because Web2 security is kind of convoluted right now, but the Web3 security back in the days was super new, like Web3 security. So I decided to move there. And after basically I did a lot of self-learning, and fun fact that my first language in Web3 was Solidity. I mean, not surprised there technically because it was it was super mainstream back in the days. I mean, still is, but I mean, back in the days it was like the only choice you had.
I'm sorry, Timur. I think your microphone right now he switched to headphones. Can you check it? Because I think.
Yep, 1 second.
Yeah, because
I mean, if it is, yes, that's true.
What about now?
Oh, 100. Oh my God, that's a studio sound now. That's a different thing.
Yeah.
Right.
Yeah. So basically, I switched to Web3 security, and after basically a lot of self-learning, I was doing like a Solidity, even did like a couple of Solidity audits. I moved to Halborn, and there I decided just to pick my path to be just fully focusing on Rust, doing Rust audits on Near Protocol, Substrate, sometimes just pure Rust programs. And then I was basically leading security engineering teams, basically Rust security engineering teams there. So that's pretty much it. And then I moved to after Halborn, I co-founded TrustBlock, where we are building a new way of how audits can be published on chain. And that basically our goal is for people to, when they visit any project, to know exactly whether the project is secure or not, and also secure integrations between different projects in a Web3 ecosystem.
Oh, sounds good. So overall, how much time have you spent in Web3 security already? Approximately.
From 2020, it's like around I would say 3 years roughly. I would say around like a 2.5, 3 years in Web3 security field. And but it was like a hell of a 3 years, I would say. So
how was the 2020 for security space? Like, was it different than today? Was it more immature?
Yes, yes,
compare
it
this?
was like back in the days, like 2021, 2020. I would say it was easier to find bugs back in the days, because everything was super new. Like people didn't know how to write like a proper smart contracts. Everyone was learning. There weren't so many resources out there how to write secure smart contracts as we have now, and it was like on Solidity side also, and again on Rust side, again back in the days we could easily discover many basic access control issues, which is super rare, at least from my experience right now, to find at least on a Rust project. So yeah, back in the days, it was a lot easier to find bugs, but now bugs got a bit more crazier. So yeah.
Gotcha. That's true. That's interesting, actually. So let's move for next question. Can you tell about your current work, like what you do in TrustBlock right now? Like, what is the main goal for TrustBlock? You briefly covered this during your introduction, but basically, can you go more in depth for what kind of infrastructure you're building in TrustBlock for Web3 space?
Yeah, sure thing. So basically, as I mentioned, like our vision of TrustBlock is to build something, let's say HTTPS for project security, meaning that if someone visits um, a certain project, they can know exactly whether project is scam or just simply secure, because like many users have no idea. Like we're living in a bubble. If the regular user joins, let's say Web3 space and tries to visit certain website, they have no idea where to look at, where to check its security. They have no idea what the audit is, and that's what we're trying to achieve. And we basically work on a data consumer and producer model, meaning that security data producers are our audit firm partners that we onboard to TrustBlock. They produce security data for us, such as like they upload audits to TrustBlock, and in return they get like a business metrics that they can use to attract more leads. And we then basically use that data and give it to consumers, such as, let's say, big platforms like CoinMarketCap can use our data to enhance their, let's say, metrics on their coins. They can display whether coin is secure or not, how many audits were there, was there a recent bug, and so on and so forth. And also we building right now everything currently at this stage is off chain, but we actively right now building a security audit registry that is going to be fully on chain. And how it's going to work is that any project that integrates with us will be able to reactively, let's say, if a token wants to join a bridge and bridge uses TrustBlock, they can easily check whether that token has an audit or is secure, and then decide upon that to accept it to a bridge, or DEX likewise can do the same. And the fun part is that we're trying to make it try to make our data reactive, meaning if there was, let's say, a new bug discovered, we can directly mark a new project as insecure, and so that any other protocols that integrate our data can directly pause any actions with that token, let's say, on a DEX. I won't be getting into more, like, say, technical details, how we use it, how we do it. We are building some more solutions that we're going to release soon, and we gonna talk about that later on, I would say.
Sounds interesting. So yeah, first thing that comes to my mind when you talk about on-chain data is the standardization that is like a big gap right now for Web3 security, basically, because cybersecurity is very developed in this terms of like there is a lot of registries for bugs, there is a lot of registry for security companies and stuff like this. So yeah, for Web3 security we don't have something like this, and what you are actually building, from my perspective, this can lead to like first steps towards standardization of like Web3 security data, and this is a great step in the forward the security, like accelerating security in our space. That's cool. And yeah, that's interesting. And yeah, Carlos, your question.
Yeah, I'm wondering, can you give us an overview of Rust adoption in Web3 and which change, in your opinion, provide the best developer experience? I'm wondering also about the Rust for smart contract focus, right?
Sorry, couldn't hear your last part.
Yeah, I'm wondering, I'm interested. I know that like when you search for learning about Rust, there is mainly a lot of things about not smart contracts connected, right? So I'm wondering, so an overview of Rust adoption on Web3 security and smart contracts.
Yeah, so basically, just to give you like a quick overview of the, let's say, Rust adoption in Web3. Right now, it's I mean, still Solidity is dominating. That's true, but still, like there are more and more, let's say, chains built with Rust. Let's say Substrate is the whole framework written in Rust that you can use to build chains, which are then connected to Polkadot or Kusama or whatever. There's also Solana that actually was, when I was working back at Halborn, when Solana came out, it's actually became, I would say, the most popular Rust-based chain back in the days, and many people started building on it. And I would say from that time, Rust was getting more and more popular in Web3. And also in addition to this, if you know like Paradigm, VC fund, those guys are actually actively trying to utilize Rust in their open source projects, like releasing like the recent ones. They're like they built like a MEF framework written on Rust. And their CTO is also like super Rust fanatic, so they are also having like many projects written on Rust, which actually just popularizes the language among the Web3 ecosystem. And Rust for smart contracts, I would say the chain that, from my experience, that I worked at and written smart contracts at, is the easiest one so far is the Near protocol. I know it might be a bit of shell since I also created a course about this, but I would always suggest, if you, let's say, have already a knowledge in Solidity, you have already a knowledge in what a smart contract is, how it works, instead of trying to, let's say, go and do, let's say, use Substrate to build a whole chain yourself in Rust, which is a lot harder than writing smart contract. You could go to a Near protocol. Those guys, the whole motto is to make Near protocol should be consumer centric and easy to use for both developers and regular users. So they built a lot of, let's say, testing tools that you can easily use. Their whole API in Rust to write smart contracts super easy. You can literally just add a macro on top, and you already have a possibility. You don't have to even code it yourself. So there is like a lot of nice things built around that. So writing smart contracts on Near is so easy, and I would argue it sometimes reads as easy as in Solidity. So that's my take on this. Ink is also good, but I haven't spent that much time on Ink. I would say it's also similar to Near, but for now, I would say if you want to just directly start with in Rust smart contract world, just go and try Near protocol. Let's say if you just starting out in a smart contract world, you never touched blockchains or anything else, and you have no idea about Rust or any, let's say you're coming from a JavaScript world or something else, I would argue don't start with Rust. You should start with Solidity. It's easier. Just you should learn how to navigate Web3 world, how to write basic smart contract, understand what's happening. And for now, Solidity provides easier developer experience for starters. So if you have no idea about Web3, start learn Solidity, at least do the basics, like do open a remix, do some stuff. But then when you actually move to Rust, you'll appreciate it more also. That's what I would say. And if you're already, let's say, in the Web3 space, you know Solidity and want to start with Rust, the best way would be to first don't even like maybe do any, at least I'm going to share my experience how I learned it. So you don't even touch the Web3 things. Try to learn the basics of a language, build some random CLI, maybe like relate to a Web3 or not. Just learn the basics of a language so that you can navigate it easily, know how to navigate documentation in Rust. It's super important because sometimes you have to know the types and you have to know how to navigate, let's say, crates.io or some documentation that's provided, how to generate documentation. It's super important in Rust. And then afterwards, after you cover like a super basics, maybe even like I would say reading like 10 chapters of Rust book is sufficient. You pick one chain. I would argue I would say, okay, try, let's say 1-2 chains, but focus on one for now. It will be a lot more beneficial for your Rust knowledge, and you at least gonna get accustomed to the APIs they use in a certain chain. Because how I learned the basics of Rust, written some like random CLIs and stuff. Then since I had some experience with Near, I decided to get into Near a bit more. So I written, let's say, Open Zeppelin type library for Near protocol, and that actually improved my Rust skills at the same time. So it's basically that's how I would approach learning a new language or learning new chain, just by building something. And when it comes to Web3, just to learn basics of Rust and then pick a chain and just try to write some smart contracts in it. And luckily, like at least on your protocol, there are a lot of examples and a lot of documentation that you can rely on. I mean, if you're comparing, I would say, let's say, okay, let's do the basics. I would say let's compare, not compare Rust Solidity, but just take Solidity as a baseline. I'm talking from my own experience, and when I write Rust smart contract afterwards, I'm more confident that I didn't fuck up than I write a Solidity smart contract. That's the basic, also like a first feeling when you write Rust smart contract at the end, because Rust by itself actually has so many additional security features built in, and compiler is not forgiving. Usually you eventually make less mistakes writing a smart contracts. Even let's say a basics, like Rust provides you with the many ways of let's say how to handle overflows, for instance. In Rust you can handle overflows in many different ways how you like it. It also adds the additional flexibility, and also by default, as long as you compile correctly, you won't have any overflows in your Rust. Like if you add overflow checks in your cargo toml, if you added like a checked adds, you shouldn't have any problems there. And also, I would say that's a bit, controversial. But usually, if you already know Rust, if you're writing, let's say, Rust smart contracts, you spend a long time. I mean, not a long time, but I mean, it's harder to learn Rust than Solidity, and because of this, barrier of entry is higher, and usually, output of smart contracts is a higher quality than in Solidity in some cases. That also plays a vital role, I would say. What compiler provides you with is that you don't one of the reasons why Rust was adopted in Web 2 in many, actually in AWS and in many other places, to first of all rewrite some stuff from C++ to Rust, is that it prevents majority of memory issues. That actually, one by itself, it's already a big reason why many people are just rewriting everything, because it's harder for a developer to write something stupid, unless you write unsafe Rust. Even in unsafe Rust, if you write unsafe Rust, it doesn't mean that borrow checker just turns off. It's just more permissive, I would say. And also in addition to this, because of its speed and basically execution and lower memory, it's super useful for serverless applications. It's we are writing currently at TrustBlock. Our whole stack is serverless. And we are planning to change some functions from we're currently writing in Node.js, basically in JavaScript, TypeScript to Rust, because execution time is going to be much lower, and therefore the cost savings are going to be higher for us. So that's also another benefit of Rust, of its speed and its memory footprint, that I would say is super beneficial. So yeah, I mean, for compiler, it's great that it just prevents so many memory issues that you can have out of the box. The only drawback is sometimes compile time, but I mean, you have to live with it. But it's not a big deal, to be honest. In some cases, one tip to learn Rust better. Many beginners are not using it. install Clippy. Like Clippy, it's basically a linter for Rust that you can use to basically go over your code and give you like some suggestions to improve your code, correct your mistakes, and so on. I cannot tell you how many times I saw like, let's say, Clippy giving me like a warning on some code, and it's explaining why it's not optimal. I didn't know about this, and I actually learned a ton from it. So that could be a nice tip for you, for anyone who is learning Rust, to start using Clippy early in your journey, alongside the regular Rust analyzer, cargo check, and so on. I would say like the best way for you to learn smart contracts is just to pick a chain, go there and read resources documentation there. Like I don't think there is like a generalized channels like that can teach you that. But still, like while you learning how to basically learning how to write smart contracts in Rust, depending on the chain, is to just learn that chain's APIs. Basically, you have a basic container of the just a regular Rust that you write, and you add additional chain APIs on top, which you're gonna make your smart contract to compile correctly so that it can be uploaded to a chain. So basically that's the core. But you still have to learn Rust, and you shouldn't be like, I should focus like 90% of my time learning the smart contract development on Rust, or learn all the APIs that exist on, let's say, on Near protocol. If you're going with that, you should also like spend some time to basically pump your regular Rust knowledge, because that's at the end of the day, that's what you're using. It's built on top of the regular Rust. So go like for resources. I shared some in I forgot the channel name, but I shared some there. There is super nice, I would say, channel and a website called Rust Adventures. It's not Web3 focused whatsoever, but you're gonna learn a ton there. You can pick a track. There is a CLI track. There is a serverless track. If you want to, let's say, build serverless application with AWS, you'll be able to learn Rust for that. Super nice resource, recommended. Some YouTube channels I mean, Let's Get Rusty is nice. Many people share it. There is one, I forgot the name. Basically, the guy from Norway, Jon or something. I shared the channel with them. From that guy, I learned Rust macros. Basically, the guy just makes 4-hour streams trying to solve challenges, and the guy one of the streams was just learn the Rust macros and was solving challenges. I learned a ton from him. But the guy, he's like a super expert. He's like was working in many different companies, and yeah, so it was super beneficial. There is also a super cool guy called Tim Clicks. Has a big Twitter following also, and he has a Patreon, and he's the author of the book called Rust by Example, if I'm not mistaken, which is also super nice. And he basically shares some videos about Rust, like does code reviews, and even if you fancy, you can request a code review from him. Most probably it's going to cost you money, but I mean, why not? If you want to improve, like having a code review from a cool guy, it's always good to have. Yeah, that's pretty much it. So to summarize, if you want to learn Rust for smart contract development, pick a chain, go to documentation, and try to learn from there. But don't basically underestimate just the regular Rust knowledge, because that's what you write at the end of the day. So you should use it in combination. So yeah. Okay, sure. So my experience auditing any smart contracts or chains in Rust is that at the beginning, the code might look intimidating, but more you get into it, it becomes easier, usually. I mean, makes sense, right? Like, I mean, Rust is more explicit overall, so you're gonna have like a more code overall to read. But at the end of the day, after you read it and you have experience, you built your like a reading experience of Rust, so you can easily like pinpoint where something starts, where something ends, so it becomes easier overall. And basically how I approach things, since I'm usually auditing not only on one chain but on several, is that I usually classify vulnerabilities by them being language specific or chain agnostic, or chain-specific issues. What I mean by that is language-specific issues are issues that originate from the usage of a Rust language. Those are not basically related to Near, Solana, or something. If it's written on Rust, they're going to be language-specific issues. And there is chain-specific issues, which are issues that only exist on a particular chain in the way that it was designed, in the way that it was basically how APIs is structured, and so on and so forth. So first, usually the easiest way to start is if you're new security researcher, you should just learn Rust security by itself, language Rust security. And I'm pretty sure if you go to some smart contracts or some projects written on Rust, you'll already find some issues there. Maybe not severe, but still, you'll be able to pinpoint something. And usually those are around like, I don't know, integer overflows, stack overflow sometimes, especially in chains. Some not memory issues, but I would say issues related to storage exhaustion. So yeah, those usually issues that could originate from the Rust language itself. And for chain-specific ones, I would say the easiest way to learn them is to just, as usually as in Solidity language, also is to read previous reports. Unfortunately, that's also a big issue right now in the Rust security world. There is no there is not much of common top 10s, I would say, in the Rust world. There is super recently, there was one in what I want to say. In Substrate, there was one top 10 release, common security vulnerabilities. And before that, there was nothing for the past, let's say, 2 or 3 years that I've been auditing Substrate chains. So now it's actually getting easier. Mm-hmm. What I can say about approach, how would you, if you're coming from Solidity, to actually go into Rust auditing, or Rust and you want to start auditing stuff, is to first learn Rust security. That's a must, in my opinion. And then just pick a chain and learn vulnerabilities that exist there. If there is top 10, just read top 10 and then start. If not, just try to read previous reports. And usually, and also basic stuff like logical errors exist everywhere in Solidity and Rust. So it's language agnostic. You can just find logical bugs here and there, even if you don't have any Rust security knowledge. If you, let's say, there is a new, I don't know, the popular chain that I rolled up that I'm planning to get into is Aztec network that I'm thinking of getting into. There is nothing, zero. I haven't, at least, I just, it was my limited research, but I haven't seen any common vulnerabilities or anything there. So how would you find it? If you already have experience from other places, from other chains, my go-to approach is usually just writing documentation. And fun fact, many security issues are already written in documentation in some warning sections somewhere here and there that developers not always read. So sometimes actual chain, a protocol creators write those warnings for you that you have to just write. So usually the easiest one, at the beginning, is just write the whole documentation of the thing that you're planning to build. Write a documentation of writing smart contracts in Near. Right now, if you go to a Near Protocols website and read about the how to build smart contracts on Near, you'll see there is a security recommendation section already. Mm-hmm. So yeah, so sometimes finding new chain-specific bugs is as simple as reading documentation. And then it boils down to experience, I would say. You have to read some smart contracts, understand how it works, and then you'll notice some patterns or common bugs that occur, and from there you'll understand that it's a common vulnerability. Usually, that's also another, there is there is a sole audit, but I don't know if those guys actually source non-Solidity reports, because many firms that actually Solidity has already have audits on Substrate, Near, Ink, Solana, like Halborn has. But I don't know if Solidity has them on their platform. There is like Trail of Bits, like those guys also have it. Zelic. Yeah, I guess you have to know the firms that do them and go to their GitHub and find them right now. So, I mean, unless Solidity decides to just also source non-EVM reports, which could be cool. Look, I mean, I didn't have that much of experience in Solidity auditing. I just did one, I guess, in the super very beginning of my journey. But I would say, like, overall, it's like when I audit Rust smart contract, it's always again like everyone's approach is different. Like my approach, I usually try to actually first read the documentation, then try the happy path, try to because on Rust also it's especially true. Sometimes it's super important to launch your application and then try it out if it actually works. Sometimes that can be like and also probably in Solidity also like sometimes documentation provided is incorrect or something is not launching. So my approach is, and maybe many Solidity folks would say that it's also a similar approach that is in Solidity. So I launch basically a protocol, launch a program, and try the happy path and try every single thing to ensure that everything works. Try so that expected results are received, and from there, I'm already trying to break it. So I'm reading the code and pinpointing literally function by function. Usually I just do like a quick run of the code, add some to-dos here and there, to-dos like a report or let's say try it out, some scenarios, and then I go and try them like on the deployed chain usually. So that's how I find vulnerabilities. On Substrate also, like if it's actually chain and like on Substrate also fuzzing sometimes can be used to find some vulnerabilities, especially before. In Substrate there were scenarios where if you basically panic basically in panic and execution, if storage was written before the panic, basically storage will persist even though there was an error afterwards. So you could basically fuzz several functions to ensure that they basically don't panic. So that was also one approach. Right now it's different, but yeah, that's basically it. I mean, yeah, I mean, look, I mean, if you're a beginner in like you already know Rust, but you're a beginner in like writing smart contracts in Rust, I would say go with or auditing Rust, go somewhere where it's more popular. Because at the end of the day, you also as a solo smart contract auditor, if we're talking about solo auditors, you want to make money. And if you go to, let's say, some low-key, let's say not super known protocol, you may actually spend some time learn it. And in the future it can benefit you, but at this stage I would say go to somewhere that's, as you said, like long players. They have many projects. You'll eventually you'll be able to get more gigs from there, like a Near protocol, Substrate based chains, like just quick alpha, like Polkadot right now is they're actively trying to source security researchers right now. So it's like that can be some, because they saw that there is like a lack of Rust security people in their ecosystem, and they have many big critical projects that need to be audited. So I would say go with Near, go with Substrate, go with but by Substrate I mean like Substrate chains itself and Ink also, because I mean Substrate is a framework to build blockchains, and Ink it's a smart contract language that you can run on Substrate based chains. And also, like if you already learned something, let's say Near protocol, Ink is kind of similar. Like you could apply many things. Like API is a bit similar, so you could apply some knowledge from there to another stack. That's also a beauty of Rust. Like if you know Rust, like it's already easier for you to jump on to a new chain. You just have to learn API. Yeah, for sure. I mean, there is no like a standardized tool like Slither, like for instance, like on in let's say a Near, I forgot the name. there was one tool which is also basically works similar to Slither to find vulnerabilities in near protocols, like statically. But I mean, it was in alpha back in the day, so I didn't find much success with it. That's why I prefer like a manual approach. And right now, it's mainly manual in many scenarios. You can use like also in Rust, it's super important to check dependencies. So basically, you do cargo audit, for instance, to check some for the dependencies, some out of dates. For fuzzing, usually you would use like there are many fuzzing libraries. I use like a honk fuzz, cargo fuzz. Those guys are good. Like usually, like from my experience and working with some folks, it's mostly manual approach of finding bugs. There are some internal scripts here and there. Let's say some folks have scripts to find Stack Overflows, for instance, or find recursions, because recursions are usually in the code like one of the main things that can lead to a Stack Overflow. So some folks have scripts to find recursions in the code, but there is no like a standardized tooling, at least now, to find security vulnerabilities in many Rust-based chains. So you could be one to create it. That's also another thing. Like it's open field. Like maybe you're gonna be the one who's gonna create such thing.
Cool though. We need more of them. 100%. Okay.
Yeah, guys. I think we asked most of our questions that we wanted to ask. We covered everything even beforehand, before our last question. So thank you, guys, and have a good one.
Yeah, bye-bye, everyone.
Thank you.
Thank you. Have a nice one.
Bye-bye.
Bye.